Welcome everyone to The Explainer. Today we are completely demystifying Cambridge IGCSE additional mathematics, specifically focusing on syllabus 0606. I want you to picture your upcoming exam as the championship final. You've got 90 minutes to glory, you've done the training, you know the plays, but today we're zeroing in on your game plan for absolute victory. We're going to tackle a crucial, heavily penalized formatting trap that consistently costs even the brightest students incredibly easy marks. We're locking down your strategy today so you do not drop points right at the finish line. Let's get into it.
So why do top students lose marks on simple notation? It's incredibly frustrating when you deeply, genuinely understand the complex math behind a problem, but you end up losing points on the formatting. We see this all the time. Imagine two students, Alex and Sam. Alex overloads their paper with raw mathematics facts, but there's zero analysis. Sam just rushes and completely misses the command word requirements. They both know the math, but their answers end up covered in red pen. Why? Because mathematics is a language with incredibly strict grammatical rules, and relying on shorthand is a massive mistake. We're going to dive into exactly why top candidates like Alex and Sam stumble on simple notation conventions, and how you can guarantee that you avoid their fate.
Here's our roadmap for today. Section 1, the notation trap. Section 2, core mathematical principles. Section 3, the method mark strategy. And Section 4, expert examiner insights.
Starting with Section 1, the notation trap, and specifically the f squared of x misconception. Let's compare the notation. Look, in standard algebra, writing f squared of x universally signals a composite function, right? It means f of x. But applying this exact same algebraic format to trigonometric functions is a major mathematical faux pas. This is exactly where our student Alex lost marks. When you want to square a trigonometric function, the proper notation is strictly sine squared of x. That means the sine of x all squared. Mixing these up shows the examiner a fundamental misunderstanding of math vocabulary. It's kind of like trying to order a coffee in French but using Spanish grammar. The examiner might guess what you mean, but they definitely are not going to give you the marks for fluency.
The absolute rule you need to memorize right now is simple. The notation f squared of x is never used with trigonometric functions. Examiners have incredibly strict conventions. If you apply the algebraic composite notation to a trig function, hoping the examiner will just know what you meant, you are going to get penalized. It is completely invalid, and it will instantly cost you marks, even if your final calculation happens to be spot on. Now, before we continue and look at how to build the perfect answer, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
All right, moving to Section 2, core mathematical principles. This is all about building the architecture of your answers. Cambridge's assessment objectives reveal exactly what examiners are grading. The syllabus targets 3 distinct cognitive domains, and they're weighed equally: your raw knowledge, your application, and your analysis. If you just memorize formulas without mastering precise notation, like that trig rule we just covered, you're really only hitting that first slice of the pie. You are completely missing out on demonstrating true application and analytical depth, which, let's be real, is exactly where the top-tier grades are decided. You have to show them you understand the command words. To hit all 3 of those cognitive domains effectively, your mathematical architecture has to rest on these 3 pillars. First up, precise definitions. This means using the exact notation required every single time. Second, understanding causal relationships, meaning how one mathematical step logically dictates the next one. And third, cross-topic integration. Principal examiner reports continually highlight that candidates who can explicitly reference cross-topic connections, say beautifully integrating calculus with trigonometry using perfect notation, they are the ones who achieve significantly higher marks. Let's dive into Section 3, the method mark strategy. This is all about process over product. The method mark strategy is a total game changer. It means you absolutely must secure marks for your analytical process. In additional mathematics, your final answer is literally just the tip of the iceberg. Examiners are actively looking for clear notation, correct terminology, and step-by-step execution. You can make a tiny arithmetic error on the very last line, but if you perfectly demonstrate the method using flawless notation, you'll still capture the vast majority of the points. This is where you want to think about frameworks like PEAL, point, evidence, explanation, link, to structure your logical flow. But if your working is invisible or uses improper shorthand, you forfeit that entire safety net. So, whenever you tackle a complex problem, I need you to rigidly follow this 5-step standardized sequence. First, identify the key elements from the text. Second, apply the relevant principles. Third, and this is exactly where those method marks live, execute your analysis with clear, readable working. Fourth, verify your results. And fifth, Present it in the appropriate format with correct annotations. Make this sequence an automatic habit, and you guarantee that you capture every possible method mark along the way. And hey, stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Moving on to our final section, Expert Examiner Insights. Let's figure out how to avoid the biggest traps. These are the top 3 massive mistakes highlighted year after year by the principal examiners. Number 1, students failing to provide specific analytical depth. Their answers are just far too vague. Number 2, neglecting presentation conventions, which totally includes messy layouts and using band notations like we talked about earlier. And number 3, ignoring the specific context given, which means failing to connect their mathematical answers back to the actual scenario in the prompt. If you scan any past paper data, you will immediately find these flaws costing students their target grades. Listen very closely to this examiner alert. Providing a generic mathematical answer without tying it directly to the context of the question is the ultimate trap. The examiners state clearly that academic benchmarks require logical, structured reasoning that actually fits the specific data interpretation required by the question. You absolutely cannot just copy-paste a memorized response into the booklet. It has to be tailored to the exact problem sitting in front of you.
To combat these mistakes and completely satisfy the examiners, you need to adopt the deconstruct, solve, evaluate method as your mental model in the exam room. It works a lot like the Peel framework we mentioned. Deconstruct the problem, identify the given information, and break it down into logical steps. Solve it systematically, using that flawless notation we've been emphasizing. Finally, evaluate it. Check if your answer is mathematically reasonable and make justified recommendations based on your evidence. This framework ensures you logically hit every single syllabus requirement without missing a beat.
I want to leave you with this incredibly powerful observation taken directly from the syllabus documentation. Top-performing students exhibit connected, conceptual understanding transferable to unfamiliar contexts. The absolute best students don't just memorize isolated rules. They build a deep, connected understanding of the mathematical language. Because they truly understand why notation works the way it does, they can adapt and thrive when the exam throws a completely unfamiliar surprise question their way. And look, students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, @acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. So, as you head into your exam prep, I want you to ask yourself a serious question. Are you going to risk it all by relying just on your final answer, hoping your messy shorthand makes sense to whoever is grading it? Or will you use the precise notations and the deconstruct, solve, evaluate method to secure every single method mark available? Master the language of mathematics, perfect your formatting, and go ace that championship final. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study